Okay, ladies, I'm going to give you a few notes on a couple of kinds of problems that often show up on the PSAT. You have your handout in front of you. The first one that we're going to do is looking at how to find the lengths of sides of triangles, or some information about finding the lengths of sides of triangles. The first thing I'm going to review is something that you know very well, which is the Pythagorean theorem. Usually you see it written this way: a squared plus b squared equals c squared. I'm sure you've all seen this. I need to make sure that you know that the A and B represent the legs of the triangle, and that C represents the hypotenuse. The hypotenuse is always the longest side, and the legs are the two sides that actually form the right triangle. Sometimes people get a little bit mixed up about that. So I've got a few quick examples here. We have this side is 3 and this side is 4. They form the right triangle, so both of these are the legs. So they're going to be A and B. And this side over here that's missing is going to be the hypotenuse, so that's going to take the place of C. So you just write that out as 3 squared plus 4 squared equals C squared. Grab your calculator, pop those numbers in, and you'll get that C squared is equal to 25. And in order to find C, you need to take the square root of both sides. So C is equal to the square root of 25, or C is equal to 5. And that gives you the length of the missing side of a right triangle. Again, this only works for right triangles. Okay, for the second example, this number 5 right here is a leg, but number 13 is not one of the sides of that right angle. So the number 13 is the hypotenuse. Okay, and that means that this missing side over here is one of the legs. You can either call it A or you can call it B. It doesn't make any difference at all. So on this one, you would set it up as, say, 5 squared plus b squared equals 13 squared. Or maybe a little more useful, b squared is 13 squared minus 5 squared. 13 is going to be the longest side. You're looking for one of the shorter sides, so you're going to have to subtract. Again, grab your calculator. Let the calculator do a little bit of work for you. And you get that b squared is equal to 144. And that gives me b is equal to the square root of 144, which is 12. Okay, that's how you use the Pythagorean theorem in right triangles. Now what the PSAT likes to do is pop this into problems that have multiple shapes combined. And you just have to make sure that you see this visual part, recognizing that if this number right here is A, but you can also put an A there. And if this number is A, but you can also put an A there. And here we have a right triangle with a missing side right here. You need to identify if the missing side is a hypotenuse or if it's a leg. And in this case, it's part of what forms the right triangle. So this missing side is a leg, and the 17 is the hypotenuse. All right? So you can start it out either way you want to. It's addition, 8 squared plus, call it A or B, it doesn't matter. A squared equals 17 squared. Or I like to do it again by saying the missing leg is going to be the hypotenuse squared minus the other leg squared, the missing leg squared. One more time, grab that calculator, pop those numbers in, and A squared equals 225. And so A is equal to the square root of 225, which is 15. So I'm pretty sure y'all have all worked with right triangles before. Just look out for them somewhere in the PSAT. There's often a shape that has a missing side that's a right triangle that you can use the Pythagorean theorem for. In this case, the PSAT might ask you to find the perimeter of this or the area of this, in which case the first thing you would need to do is find that missing side of 15. Okay? All right, turn the handout over. And this piece of information is not something that's generally covered in middle school math. Usually it gets covered in geometry classes, and it's this right here. The sum of any two sides of a triangle is greater than the third side. Okay, so if you draw any particular triangle and you give them 3 sides, A, B, and C, it does not have to be a right triangle for this. Any triangle at all, this has to be true. If you add up A and B, that must be greater than C. That has to be true. Also, if you add up A and C, that has to be greater than B. And the third one is if you add up B and C, that has to be greater than A. This is true for every triangle. And they love to put this on the PSAT and they're going on your practice, on your assignment number 2. So we're just going to check through and see, can you make a triangle with sides 5, 6, and 7 using this rule? Okay, so just pick the first two, 5 plus 6, and ask yourself, is that greater than 9? And it's 11, so yes it is. And then do 5 plus 9 and ask yourself, is that greater than 6? And the answer is yes it is. And then go back and pick the 6 and the 9 and ask yourself, is that greater than 5? And yes it is. That means that yes, I could make a triangle that has these 3 sides. This is possible, okay? Take a look at the second one, 3, 6, and 8. So I'll start with the first two. If I add 3 and 6, is that greater than 8? Yes. If I add 3 and 8, is that greater than 6? Yes. And if I add 8 and 6, is that greater than 3? Yes. Again, I can take 3 sides, 3, 6, and 8, and create a triangle that has those 3 sides. Okay? One more. If I take 1 and 3, is that greater than 5? And the answer is no. I don't have to go any further. It doesn't matter if the other things are true, and they both happen to be true. I guess I'll put them up here real quick. 1 and 5 is greater than 3, and 3 and 5 is greater than 1. Those work, but if one of them doesn't work, then that means you cannot create a triangle with sides 1, 3, and 5. So if you have a little short side of 1, and then another little short side of 3, then this 5 is probably going to be too long. There's no way that you can create one that's going to work out with that 5. When you take geometry, teachers usually do some hands-on work with this one to show you that it's true. Okay? All right. This, I believe, if I've written the right problem down, will help you with problem number, I'm sorry, it might be number 20. Apparently I didn't write the problem down. Okay? But there is one on your PSAT that asks this question. Okay? All right, flip over on the other side. This is a different topic. There's a lot of times they ask you to find an area of figures, and instead of telling you how long the sides are, they drop it on an X and Y axis. So you just have to figure out the lengths of the sides by recognizing that you can count from where this begins, here at 1, 2, 3, 4, 5, 6 to 6, and recognize that that distance is going to give you the length of the side, which is 5. That's pretty easy. This is 1, 2, 3, 4, 5, and so this distance right here is going to give you the length of this side, which is 3. So the area of this is 3 times 5, 15. Okay, that one's pretty straightforward. So is the next one. Just make sure you know how long those sides are by connecting it down here to the coordinate system. So this is 3 and this is 5, so the distance from 3 to 5 is 2. And then over here, this is 2, and this is 5. That distance is 3. And then make sure you don't forget the formula for the area of the triangle, which is 1/2 base times height, and that gives me an area of 3. Okay? Now, in finding the area of triangles, whether they're right triangles or not, the two numbers that you use for base and height have to be perpendicular to each other. So in this problem I did, the base and the height, one was horizontal and one was vertical. When you look at this one right here, these do not appear to be perpendicular to each other. So here's the thing, if you use this as your base, you have to use this distance right here from the top to the top vertex down to the base, which is perpendicular, to get you your height. Okay, so once again, you just want to count off how long this base is. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the big danger here is that you will accidentally call this 9. This is not 9. It starts at 1 and it goes to 9, so that distance is 8. Okay? All right? And the height is not the length of the leg. The height is that perpendicular distance from the base, from this base here, up to this vertex. So that starts at 1, 2, 3, 4, goes up to 4, and so that height is 3. The area of this triangle is 1/2, 8 times 3, which gives you 12. Now, if you prefer to do this, and I'll show you another way that you can do this, you can cut this triangle, let me erase this work, erase this. You can cut this triangle into 2 right triangles, and that sometimes is very helpful. If you just physically cut it into two right triangles, and then do area 1 and area 2 and add them together. Okay, so that this number 1, 2, 3, 4, this one for area 1 would be 1/2 base, that height is still 3 times height, and area 2 would be 1/2 5 times 3, and I'd be happy with my calculator here, but 9 halves plus 15 halves is 24 halves, and 24 halves is 12. That's not a better way, it's just a different way. Okay, you see that a little bit better. Cutting up shapes into smaller pieces can sometimes make it easier to find an answer. All right, turn that over on the back. And then here's this weird triangle that's pushed over to the side, and the key here is to recognize what your base and your height is. So if I take this as my base, right here, the screen, this is going to be 2, 3, 4, 5. That distance will be 3. Then my height has to be perpendicular to this. It has to go straight up like this. And it never meets the vertex, which is way over here. So what we usually do, is, is sort of pretend like it goes out like this, like that. And that distance right there is your height. So that's going to go from 1, 2, 3, 4, 5, up to 5, and that distance will be 4. So we'll look at a couple of ways you could do this. You could just use this as the base. This distance here is the base. This is the height, and that will work. 1/2 times 3 times 4, which is 6. Or you could see it as a big right triangle. Sometimes finding right triangles is easier. This is a big right triangle, 5, 6, 7, 8, 9. And that would be 1/2 times 7 times 4. And then subtract away this part that I just shaded green, subtract that off of there, minus 1/2, 4 times 4. And that gives me 28 times 4, 14 minus 8, and 14 minus 8 is 6. So sometimes people prefer to work these with right triangles and add them or subtract them to get the answers. Okay, now this last one actually looks very similar to one that's on your practice quiz somewhere. And when you get ready to work this problem, you want to think about how you want to cut this up. You can cut it up into triangles like this, but finding that base is tricky because it is not a right triangle and it's not horizontal or vertical. You can do the same thing here. And once again, not right triangles, not horizontal or vertical, and that's a little bit tricky. So I'm just going to work this problem kind of a long way, but only using right triangles to figure this answer out. Only using right triangles, okay? So I'm going to get some of my numbers on here. 1, 3, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, and 6. I think I've got everything for those vertices. I think I got it all. Okay? So what I'm going to do first is I'm going to draw an imaginary rectangle around this shape. Imaginary rectangle. And I'm going to see that I have 4 right triangles. I've created 4 right triangles in the corner. 1, 2, 3, 4. And what you can do to find this area using only right triangles is to find the area of the rectangle and then subtract from it area 1, area 2, area 3, and area 4. And those areas tend to be easier to find because they are right triangles. Okay? All right, so area of the rectangle is all the way across, that's 9. And all the way up, and that is 6. That's the area of the rectangle. So I'm going to subtract off area 1. 1/2, grab another color. The base of area 1 is 3, and the height of area 1 is 2, minus 1/2, grab another color. The base of area 2 goes from 3 to 9. And from 3 to 9 is 6. And the height of area 2, oh, so this is the number over there. That one is 3. Goes from 0 to 3, so that height is 3. Okay? And then I'll switch over to area 3, 1/2. That blue again. The base right here goes from, that's from 5 to 9, so that distance is 4. And the height from 3 up to 6, that height is 3. And then I'll switch over to the fourth one, that's this one right here, the base of that goes from 0 to 5, so that's 5. And the height goes from 2 up to 6, so that is 3. Okay? And then you can do this with your calculator, or you can do it without your calculator, whichever makes you happier. 54 minus 3 minus 9 minus 6 and minus 15 over 2. One of those did not come out to be a nice number. Anyway, wait a minute, I got to put it on here. That last height, I did from 2 to 6, right there, from 2 to 6, that's 4, not 3. And that's 4. Above all, make sure you count right. Okay? So that's not 15 over 2, that is 10. And again, you got your calculator. So just pick up the calculator and do your arithmetic on that. And I forgot to do that before I made my notes up. All right. Each time to do it as well. 4 minus 3 minus 9 minus 6 and minus 10. And I get an area of 26. Okay. Now, if you think that I made a mistake in one of these computations, talk about it with your friends. See if you can come up with what you think I meant together. And I apologize in advance. There are 2 problems on your PSAT. One, this should help, and one about this, the sides of the triangle. 2 problems on there, all right? And now you have about 30 minutes to work on your PSAT stuff.